So this is the first video that in a series of the videos that I'll continue doing with patterns, and this pattern is going to be strategy pattern, and I'm using the Head First Design Patterns book, which is actually for Java. And basically in this book, like I already know, we have this arbitrary application simu-duck, and they're trying to basically add another behavior to the ducks. So they're trying to add a fly behavior, and what's happening is since all these ducks are inheriting from the duck base class, if we are running this fly behavior through some kind of list or factory generation, even the ducks that are not supposed to fly would be flying. So that's basically what this is trying to impose. So now how we would identify this in our scenarios, that's on us. So basically this first video is going to give us the shortcomings of the inheritance in this scenario. So in this scenario we have a duck base class which has some behaviors like walk, swim, and display. So all of the ducks inherit from the duck base class, and we have something like a mallard duck, redhead duck, and many other duck classes. And well, duck class is abstract and it has an abstract method display, and every subclass of the duck has to display, because obviously we have to display the duck. So we have override basically of display for each of the subclasses of duck. So each display will make the mallard duck look like a mallard, redhead look like a redhead, and every other duck look like their own type of duck. So basically here now we're showing that we have a duck such as a rubber duck, and we added a fly method here, and when we call this fly method, even in our base class, depending how this is being instantiated and how it's being run, we can run fly method for each one of our subclasses, which would mean that even a rubber duck would try to fly, and this wouldn't be correct because rubber duck is not supposed to fly. So this is the controversial aspect here, is that if we try to add the behavior to our base class, it could negatively impact our behaviors of our subclasses. So in order to fix this, we could override the fly method in rubber duck to do nothing. So in this example here we have a mallard duck, redhead duck, rubber duck, and decoy duck. And like we can see, decoy duck, we have to do the same thing because it doesn't fly or quack, so we had to override. So basically what this is implying is that even though we're using inheritance, we still have to do quite a few changes to each of our subclasses, and this is not a very good thing, as we know in programming, which we follow the principles of class should be open for extension but not for changes. So with this scenario, if we are applying the changes to each one of our classes, we're really not following that scenario, and which is not a very good thing. So the problem here is that inheritance in this case has some shortcomings, and that is if we use inheritance to provide a behavior for the classes, the shortcomings are that changes can affect other classes. First of all, like in this case, fly method affected negatively other classes, and it needed code duplication across subclasses, the fact that you're actually having to change the code instead of extend the code. And it's also hard to gain knowledge of all the behaviors that we have. They're kind of buried inside of each of the subclasses. And runtime behavior changes are difficult, which we didn't really cover this so far. They didn't really give us an example. So in a nutshell, this is first video is just to show us what shortcomings we have with just using the inheritance when we have change to our application.